One of Islam's greatest contributions to human knowledge are the geometric designs in medieval mosques. Their visual and mathematical complexity represents that of their idea of God. Concepts of infinity and overwhelming beauty are translated into their religious buildings through pattern. One of the most common ones is the Penrose pattern, which is named after Roger Penrose, a mathematician and physicist who studied the patterns in the 1970s. Penrose tiling pattern has a fivefold symmetry, which solves the problem of the mathematical aperiodic tiling, that is, tiling without arbitrary patches. Penrose tiling is considered a quasi-crystal pattern because if implemented as a physical structure, it will produce Bragg diffraction. In 1981, de Bruijn, a mathematician, explained a method to construct Penrose tilings from 5 families of parallel lines as well as a cut and project method, in which Penrose tilings are obtained as 2-dimensional projections from a 5-dimensional cubic structure. I have taken 2 shapes that compose a 5-fold larger shape for my tiling. I constructed my tiles by hand. Based on the shapes shown earlier, they appear to be derivatives of a rhomboid. I used the compass to draw a circle of 10 centimeters of diameter, and carefully measured and divided its circumference in 10 sections, of 36 degrees each. The polygon was my guideline for cutting the first shape. I drew a 5-pointed star next, using a similar method, with the compass and dividing the lines on 36 degrees each in the circumference. I marked 2 centimeters every other line from the circumference to the center, for the concave points of the star. The next section of the video shows my tiles cut and painted. I experimented with a few arrangements. If arranged properly, this tiling can go on infinitely.